This is where we had ended off, so we just have a little bit that was part of the last section, and then we can look at how do we find our line of best fit using our graphing calculator. How do we find the best line of best fit? So some things in general, we have our slope or our gradient. That's how much your y increases each time your x increases by 1. And we use that slope. We found our slope with our line of best fit by using our median point and finding another point on our line. Okay? So often they'll get you to describe what you think or how to talk about what's happening in your equation. So, study was done to investigate the relationship between age in years and the time it takes a child to run 1 kilometer. Love this test. Nothing like putting a 2-year-old down and say, go, and timing them on how long they're going to take to run. So you say, well, we need the data. Okay? They took all of that data. Okay, they only used children between 7 and 18. 2-year-olds would probably still be running. And they came up with this equation. So we've got our equation. Our slope is -0.5. Our y-intercept is 20. And if you were asked to interpret what they mean, well, you could say about the slope that for every year a child's age increases, because that's your independent value along your x-axis, the time to run 1 kilometer goes down 0.5 minutes or 30 seconds. Now that was me using -0.5 as -0.5 over 1. You could have said the same thing by saying this means that for every year the child's age increases by 2 years, their time to run 1 kilometer goes down by 1 minute. But when talking about interpreting it, it's nice to go in increments of 1 along your x-axis and then talk about how the y value changes. In the interpretation, your interpretation has to use the values and the context of the question. You can't just say that every time the x value goes up by 1, the y value goes down by half. That wouldn't be a full interpretation in the context of the problem. The y-intercept, okay, not really relevant in this case because a child at an age of 0 can't run 1 kilometer. But if it was relevant, they could apparently do that in 20 minutes, which would be very interesting to see. Okay? The only way I can see this possible would involve a hill, and it wouldn't be appropriate in any way. Oh, I shouldn't have said that. That's bad. So here's another equation to interpret. Biologist studying the relationship between the number of trees and birds. She calculates a regression line to be 5.4 x plus 8. So what does that slope mean in our question? For every increase of 1 tree, there's an increase of 5.4 birds per hectare. And y equals 8. If you have no trees, apparently there will still be 8 birds.